Hello and welcome. Are you somebody looking to achieve the very highest grade in GCSE mathematics? If you are, then please carry on watching this, the second video in a series of 3 introductory videos aiming to answer the most frequently asked question of all. What is it that I need to do in order to achieve a grade 9 in GCSE mathematics? Now, hopefully you've already watched video 1, so you'll already be aware. We don't think there's just simply a series of topics that you need to learn. Yes, there are some higher tier topics, and there are videos that will address each of those. But as well as that, we believe there is a conceptual approach that needs to be undertaken in order to achieve the all-conquering grade 9 in GCSE maths. So please carry on watching. So this, the second video, is going to address how do we attack a GCSE problem. And to take that one stage further, we've actually broken that down into 6 bullet points. The first of those is to address, are you able to identify the mathematical topic hidden inside a question? Quite often, the most challenging questions will be presented in a written scenario, or there'll be quite a complex diagram that introduces the question. What you've got to be able to do is to identify the maths necessary to answer the question. Secondly, higher tier questions are quite often worth more marks, and they can quite often take longer to answer. So are you able to choose the most efficient method? You certainly don't want to be putting yourself under added time pressures when you're in the exam situation. Thirdly, can you extract the relevant information? In other words, when you are faced with a worded scenario, or you are faced with quite a complex diagram, can you extract the information needed? Next, can you work a problem backwards? Sometimes you might be presented with an answer and you've got to find out other information that leads to that solution. Next, on a higher tier paper, quite often your solutions will be decimals, fractions, or even surds. You need some sort of mechanism to check whether your answer is sensible. And then lastly, if you've already watched video 1, we broached the topic of proof. Are you able to communicate your answers with sufficient mathematical reasoning and justification? So what we've done, once again, we've created 10 or 11 questions that not only hope to address each of those bullet points in turn, but also span the grades from grade 7 to grade 9. So please continue to watch this second video in a series of 3. If we take question 1, I'll just read it out for starters. A cinema sells adult tickets for £8 and child tickets for £5. A family buys 7 tickets and pays £44. How many adult tickets and how many child tickets were bought? Now, you might take the approach of trial and improvement, but that certainly isn't an efficient way of working. Personally, I always take an algebraic approach. It's one of my preferred topics, and I think it is also very efficient. So let's just start off. However many adult tickets and however many child tickets were bought, we know that they have to total 7. Secondly, the adult tickets costing £8 each and the child tickets costing £5 each, we know must give a total of £44. Now, straight away, I'm hopeful that this jogs your memories into thinking about simultaneous equations. If I label the top equation number 1 and the equation below number 2, the first thing I've got to do is make one of my variables match. So I could multiply equation 1 by 8, but I'm going to choose to multiply equation 1 by 5. And that will give me 5a plus 5c equals 35. And I'm going to label that equation 3. By subtracting equation 3 from equation 2, I will eliminate one of my variables. I will be left with 3a equals 9, and dividing through both sides by 3, I have worked out that 3 adult tickets were bought. We now need to find out the number of child tickets. I can take any of these equations to substitute into, but I think everyone will agree equation 1 is the most straightforward. A plus C equals 7, but we've just worked out that A equals 3. So by substituting in, I can write 3 add C equals 7, C equals 4. You might want to check your answer, remember. So if we do 8 times 3, 24, 5 times 4 is 20, 24 add 20 gives us this overall total of £44. So let's look at question 2. We have a rectangle. Whenever possible, I look to include a diagram to add that clarity, to build our confidence from the get-go. We have an area of 84 square centimetres. The length is 5 centimetres longer than the width. So again, I can take that algebraic approach. To work out the area of a rectangle, we can do length times width, width times length. So straight away we know x open brackets, x plus 5 close brackets has to equal 84. I'm going to expand my brackets. X squared plus 5x equals 84. So although this question might look like an area problem, and in essence it is, actually the mathematical topic that's hidden within it is that of solving a quadratic equation. Now, in order to solve a quadratic equation, you must remember to make the equation equal 0, and we do that by rearranging. So I'm going to subtract 84 from both sides to leave my quadratic equaling 0. Whenever possible, I do try to factorise, and we're quite lucky here, this one actually does. We have x plus 12 in brackets and x minus 7 in brackets. So our values for x are negative 12 and 7. Now we've done the quadratic part to this problem, but then we must link it back to the scenario. And the scenario is that of area. In this case, x cannot equal negative 12 because we're looking for the length of a rectangle. And the length of a rectangle cannot take a negative value. So I'm just going to eliminate this from my thoughts. X equals 7. That's this measurement here. So our other measurement, therefore, x plus 5 equals 12 centimetres. And I will remember to put my units in. And again, let's just double check. Do these two measurements have a difference of 5? Yes, they do. And do they multiply together to give us an area of 84? Yes, they do. We can move on. Question 3. A tank is filled at a constant rate. After 6 minutes, it contains 42 litres of water. How much water will it contain after 15 minutes? There are quite a few ways of solving this problem, but personally, by working out 42 divided by 6, we know that it will be 7 litres per minute. I want to know how much water the tank will contain after 15 minutes. 7 times 15 equals 105 litres. I could have done 42 multiplied by 2.5 because 6 times 2.5 is 15, but that can provide my method for checking. 42 times 2.5 is indeed 105. If I scroll down, we can look at question 4. A bag contains only red, blue and green counters. The probability of selecting a red counter is 2/5. The probability of selecting a blue counter is 1/4. The bag contains 80 counters. How many green counters are there? Well, I could do 2/5, add a quarter, subtract the answer from 1. That will tell me the fraction that are green, and then work out that fraction of 80. But we've got to be efficient. On this occasion, I actually think it's just as quick to find out 2/5 of 80. In other words, how many red counters are there? 80 divided by 5 gives us 16. 16 times 2, so that will give us 32 red. A blue counter, 80 divided by 4. I will write the times 1 in just for consistency. That will give us 20 blue counters. But we need the number of green. Well, 32 add 20 gives us 52. The rest must be green because there are only red, blue and green counters. 80 subtract 52 equals 28. And again, it is worth checking. 32 add 20 gives us 52. 52 add 28 gives us that total of 80. Now the next set of questions move on from the grade 7 plus and instead start looking at grade 8. A sequence begins. Now, because I need some space for my working out, I'm just going to rewrite that original sequence: 4, 11, 22, 37, and 56. We then have an ellipsis that indicates that sequence is infinite. Now, as always, when looking for the nth term of a sequence, I'm just going to start off by finding the common difference. And straight away, in actual fact, there isn't a common difference. What that tells me is that this sequence is most likely, because we're at GCSE level, is most likely going to be a quadratic sequence. We can confirm that, though, by doing the difference again. You may have heard of this referred to as delta 2, difference 2. And yes, on this occasion, we do have a constant second difference. So we were right, our nth term is going to be a quadratic. Now, the coefficient of our quadratic is half of the second difference, half of delta 2. I use a triangle to represent delta. Half of delta 2, in other words, what's half of 4? Well, that's 2. So our sequence, the nth term for our sequence has got to begin with 2n squared. Now, if we're beginning with 2n squared, let's actually work that out. Here, n is 1, n is 2, the third term, the fourth term, the fifth term, and so on. Well, 1 squared is 1. 1 times 2 gives us 2. 2 squared is 4. 4 times 2 is 8. 3 squared is 9. 2 nines are 18. 4 squared is 16. 16 times 2 is 32. 5 squared is 50. 5 squared is 25. Times 2 is 50. I was just getting ahead of myself. So what is it that we have left over? Already 2n squared is generating 2, 8, 18, 32, 50. But we need 4, 11, 22, 37, 56, and so on. So let's look at what we're left with. The term subtracts what we already have. 4 subtract 2 is 2. 11 subtract 8 is 3. 22 subtract 18 is 4. 37 subtract 32 gives us 5. And 56 subtract 50 gives us 6. I know it's a very straightforward sequence we've been left with, but I will do it properly. Straight away, we can see this time we do have a common difference straight away. So to generate this sequence, it will be a linear n term. The common difference is 1. I could put a 1 in front of the n, but I'm sure at this stage you know we don't have to. When the coefficient is 1, we can just write n. I just put my common difference at the front, and I simply ask myself, how do I get from my common difference, which in this case is 1, to the first term, which in this case is 2? To get from 1 to 2, I just need to add 1. So the nth term for this linear part of our rule is n plus 1. We then combine that with the 2n squared that we already have. That gives us the overall nth term for this sequence of 2n squared plus n plus 1. Now that's one of those questions that does take longer to answer that I mentioned previously, so please try and work as efficiently as possible. But remember, keep watching. We are still on the grade 8 questions that we've identified. Please keep watching for those grade 9 questions. Question 6. A car travels 180 miles. For the first half of the journey, it travels at 45 miles per hour. For the second half of the journey, it travels at 60 miles per hour. The average speed is 52.5 miles per hour because this is halfway between 45 and 60. Is the student correct? Okay, so let's just have a look. The first half of the journey. Well, half of the journey will give us 90 miles. Well, how long will the first half of the journey take? If we're travelling at 45 miles per hour, I'm pretty confident you'll be able to do this in your head. 90 divided by 45, in other words, distance divided by speed, will give us 2 hours. The second half of the journey, again, distance divided by speed, 90 divided by 60, will give us 1.5 hours. The average speed for the whole journey. Well, the whole journey is 180. The total time taken for the journey is 3.5. Now, I think this student is going to be quite close, 52.5. You can estimate here, 180 divided by 3 is 60. So it's going to be less than 60. At this point, I would suggest taking a calculator because it is going to be close. 180 divided by 3.5, execute. I've just got to, this is why we need to get familiar with our calculators. I'm actually getting, and it is close, is 51.42. Is the student correct? No. And we've explained our answer through our calculations. We're not waffling on. So we're now moving on to question 7. And the second word I see is the word square. Whenever shapes are involved, I do like to take a drawing. And the square has a side length of x. I could mark each side. Square has every side of equal length. I'm just going to label the one. We then have a rectangle. Sorry, I've drawn a square again. Let me draw a rectangle. And the rectangle has length x plus 4 and x minus 3. The areas are the same. Now, to work out the area of a square and a rectangle, actually, it's length times width. So the area of our square will give us x squared. And the area of our rectangle will be x minus 3 multiplied by x plus 4. Of course, I'm putting my terms in brackets there just to increase the clarity. So if I expand my brackets, I will get x squared equals x squared plus 4x minus 3x minus 12. I'm just going to collect my like terms. X squared equals x squared plus x minus 12. Now you might think we have a quadratic equation here to solve, but we have an x squared term on both sides of the equal sign. So actually, I can subtract x squared from both sides because I will still be balancing my equation. So that will leave me with 0 equals x minus 12. I can then isolate the x, because that's what we're trying to do. We're trying to find the value of x by doing the inverse operation of minus 12. Well, the inverse of minus 12 is add 12. And remember, I must balance, so I do it to both sides. So our value of x is 12. And again, let's now check our answer. The area of the square would simply be 12 times 12, which is 144. The area of our rectangle, well, 12 minus 3 will give us 9. 12 add 4 will give us 16. 9 times 16 also gives us 144. It's always important to check. A, are we accurate? But B, that will eliminate any careless errors from our work. Let me scroll down to question 8. A phone is reduced in price by 25%. The sale price is £360. The phone is later increased by 25%. A customer says the phone will return to its original price. Explain why the customer is incorrect. Well, the first thing I would do is simply say £360 must have the value of 75% of the original price. If it's been reduced by 25%, we've lost 25% out of that original 100%, we're left with 75%. If I divide each side by 3, £120 would have the value of 25% of the original price. And then I want to know the original price, so I'll times each side by 4. So the original price of our phone was £480. That's our original price. Now the customer is saying that if we increase 360 by 25%, it will take us back to that original price. Well, 25% of 360, well, that's a quarter. The easy way to find a quarter, let's work efficiently, is to half and half again. Half of 360 is 180. Half of 180 is 90. So by the customer's calculations, 360 add 90 should take us to our original value, but it doesn't. It only takes us to 450. Explain why the customer is incorrect. Well, simply put, 25% of 480 is greater than 25% of 360. And this touches upon the topic that you may have heard of reverse percentages. Please continue watching as we now approach the grade 9 topics. And again, look at the problem. Lots of words. We've got to take out the mathematical information we need. A farmer has chickens and rabbits. There are 35 animals altogether. Right, before I go any further, this resembles that first question, in my opinion. where we had adult and child cinema tickets, I think it was. This time we have chickens and rabbits. Essentially, we have variables. In the first question, it was A and C. This time we have C and R. The total number of legs is 94. Worth remembering here, sounds common sense. Chickens do only have 2 legs. Rabbits, 4 legs. So however many chickens there are multiplied by 2, however many rabbits there are multiplied by 4, and the total number of legs is 94. Let's call that equation 2. Again, you could multiply equation 1 by 2. I'm going to multiply equation 1 by 4 so that I'm once again making that second variable match. 35 times 4, let's work efficiently. So times by 4, we double again. So that leaves me with 4c plus 4r equals 140. And that has created us equation 3. This time, to eliminate a variable, I'm going to do equation 3 subtract equation 2. That will give us 2c equals 46. Therefore, c equals 23. In other words, we have 23 chickens. You can take any one of your 3 equations that you've created. I'm going to take the first equation just because it's the most simple looking. And we've got to substitute in for our value of c. So c plus r equals 35, but c equals 23. Let's substitute in. 23 plus r equals 35. R equals 12. Let's just check. 23 add 12. Yes, it does equal 35. 2 times 23 is 46. 46 add 48. Yes, that does equal 94. Scrolling down. A positive integer, whole number. Let's just call this positive integer x. The number is multiplied by itself. Well, if you multiply by something by itself, it means we're squaring the number. And then 6 is added. The result is 55. Find the original number. Well, with simple rearranging, x squared equals 49. The opposite or the inverse of x squared is square root. So we could say x equals, remember the square root of 49. If you're one of those people looking for a grade 9, you can't simply say 7. The square root of 49 is plus or minus 7. But let's read the question again. This is where checking is so crucial. A positive integer. So in this case, we do only want our positive solution. Really, the maths there is quite simple, but it's making sure we're reading the question and we understand what is being asked of us. So then let's finish this video now with a challenge question, an Olympiad-style GCSE question. A number is written on a calculator display. The number is increased by 20%. Okay, so let's say our starting number once again is x. Again, I'm being consistent. I'm using x for my algebra. I'm trying to increase that clarity, and with clarity, we're building confidence. A number is increased, x, by 20%. I'm just going to use the multiply method. To increase a number by 20%, we multiply by 1.2. The new number is then decreased by 20%. If you decrease something by 20%, our multiply method means we multiply by 0.8. And the final answer is 96. Well, we can do some simplifying here. 1.2 times 0.8, well, let's do 12 times 8, 96. So it will be x times 0.96 equals 96. X equals 96 divided by 0.96. X equals 100. Now, there's our original number. However, the calculator has a fault. It always rounds answers to the nearest whole number. Find all possible original numbers. So although we know the exact answer is 100, we also need to know what numbers will round to 100. Well, 99.5, 99.51, but this could go on. We could have 100.48. There is actually an infinite amount of answers that round off to 100 because you could just keep on increasing the decimal places. So actually we need to write this as an inequality. X could actually take any value that's greater than or equal to 99.5 but less than 100.5, because obviously as soon as we get to 100.5 we would round to 101. Hopefully you found this second video useful. Remember, it's an initial series of 3 videos aiming at people who are really hoping to achieve the very highest grades in GCSE Maths. So please tune into video 3. If you haven't already watched video 1, watch that as well. And of course, there will be some topic-specific videos arriving as well. Thank you very much for watching.